Hello everybody and welcome back to the channel. In this video what we're going to do is cover Matplotlib. Now Matplotlib is a library in Python that we can utilize in order to visualize our data. Specifically, we're going to be visualizing our data with graphs, which is what we typically utilize to visualize different data points. So let's go ahead and actually play around with it and see how we can create all kinds of different graphs through Matplotlib. So the first thing that we need to do is open up a Jupyter notebook. I went ahead and opened this up on my local environment. And once you have it open, well, we can start working with Matplotlib. And the first thing we need to do is actually import it. So let's go over here and I'm going to say very simply import Matplotlib. And specifically, we're going to import the pyplot method. So I'm going to say here pyplot, and then typically we give it the abbreviation of PLT. So that's the very first thing that we need to do. So now let's go ahead and actually just utilize this to create some sort of graph. Now, in order to create a graph to visualize data, we first need data. So let's quickly create a NumPy array. So we're going to have to import NumPy. So I'm going to say import NumPy as NP. And let's go ahead and we're going to say the x-axis is going to have np.arrange. And I'm going to say 0 to 11. And this is going to create an array, a NumPy array from 0 to 10, because of course this this number right over here is exclusive. So if I were to do x, for example, now you can see here we have this NumPy array from 0 to 10. Okay, so this looks pretty good. Now what I want to do is I want to create the y-axis data points. So I'm going to say here y, and I'm going to say y is equal to x times x, meaning just x squared. So now if I were to look at y, you can see here, now we have these data points. So what do I want to do now? Well, what I want to do is I actually want to visualize this data through a graph. So now we can actually utilize this PLT, Matplotlib. So what we can do here is very simply just say PLT dot plot, and then we can specify the x-axis, which is this, and then the y-axis. And then what that gives us is this wonderful graph. And let me just zoom out here a bit so you guys can see it. So you can see here that this is the x-axis that is comprised of this data, and then this over here is the y-axis that is comprised of this data. So that is pretty much what we get with Matplotlib. It's just a way where we can visualize our data. Okay, so this is looking pretty good to me, but honestly, this graph right now doesn't really mean all too much. I mean, okay, I guess that, well, the x-axis is from 0 to 10, and I can see that it's exponential, but I don't really understand the relationship here. So let's say the relationship is how fast a bacteria spreads over time. So right over here, the x-axis, let's say, is days. And then the y-axis is, we can say something like, infection rate or spread rate. So it'll be nice to actually label these axes so we can actually understand exactly what they are. So one thing that we can do in the exact same cell is specify, well, the x label as well as the y label. So over here, what we can do is we can say PLT dot, and we can say x label, and let's just say that this is going to be days. So I'm going to say days, and then similarly, what we can do here is we can say y label, and over here we can say, I can just say infections, or I don't know. I was about to say infection rates, but I guess this reaches 100, which is fine. Yeah, we can say infection rates, something like that. So over here, you can see here now we have the y label and we also have the x label. And you can see that there is an exponential growth in infection rates, as we proceed throughout the days. So you can see it's a nice exponential growth. Another nice thing that I would like to add is a title for the graph itself. So, I can just read what the title says and I can understand it right away without even having to look at the x and the y axis. So again, we can do that really simply by doing PLT and then dot title. And over here, we can specify the string. I can just say infection rates over time, something like that. And now you can see here we get this wonderful infection rates over time graph that is giving us a bunch of different information. Now, sometimes what we want to do is we want to kind of scope the x-axis or even the y-axis. We might want to do that eventually. So for example, maybe we want to only see the data points from 2 to 8. We don't want to see all of the other data points. So one thing that we can do is just say plt, and then I can say dot x and then limit, so x limit, and then over here I can say, well, I want to get it from 2 to 8. And what that's going to do is going to limit the x-axis from 2 to 8. Similarly, of course, we can go from 2 to 16 if we want to. So now that's going to increase it. Now you can see the data points, they stop at 10, so there's nothing proceeding. So that we can, of course, do that with the y-axis as well. Maybe we want it from 40 to 60. So let's go over here, and I can say dot lim. I can say it's from 40 to 60. And you can see we get this kind of really ugly graph. But if that's what you need, well, you can do that if you want to. I'm just going to go ahead and comment it out because I don't really need it. And I like the graph the way that it looks right now. Now, another thing that we can also do if we're really satisfied with this and we want to save this image somehow, some way into our local computer, what we can do is just plt.save and then fig. And then over here, we can give our figure a name. So I can just say bacteria, or I guess this is just infection rates dot png. And what this will do is save this image, this graph as an image into the directory that this Jupyter notebook is currently in. Now, I don't want to do that, so I'm not going to run it. But if that's something that you do want to do, you can go ahead and do that really easily. Okay, so now let's go ahead and move on. So the way that we have created a graph here is actually not the conventional way of creating it with Matplotlib. So typically the way that we create these visualizations are through figures. And we do it through figures because we get a lot of extra stuff that we can do with figures that we can't really do when we just go ahead and just plot an x and a y axis. And we'll actually see that throughout this course. So let's go over here, and we're going to try to just pretty much recreate everything that we created here, but this time with a figure. So I'm going to say here fig for figure, and I'm going to say that that is going to be equal to plt.figure. And what this does is, well, as you can imagine, it creates a figure. And it creates a figure of this size. And this is just the size of it in pixels. But right now you can see we have 0 axes. So axes, you can kind of think of them as the graphs themselves. So what we want to do is we want to add one graph right over here. So we're going to go ahead and add an axis. So let's go right here inside of this cell, in the same cell. I'm going to say, I'm going to create a axis. I'm going to say that this is going to be fig.addAxis. So add axis. I'm going to go ahead and invoke this, and this takes a parameter that is going to be an array, and this array needs 3 different positions. And I'm going to go ahead and explain them a little bit later, but for now we're just going to say 0, 0, 1, 1. This is not going to make a lot of sense right away, but once I do this, you can see I get this axis right over here. Let me just zoom out of here once more. So you can see that we get this. This is looking pretty good. Okay, so what does this mean? Well, I'll explain it later. I promise it is a little bit confusing. So I'll come right back to it. But now what we did was we created this axis. So now what we can do is on this axis, we can go ahead and plot our data. So we can say something like axis.plot, and we can plot x and y. And there we go. Now you can see that we have pretty much the exact same data. And we can do, of course, everything that we've done here. So if I wanted to add a x label or a y label, the syntax is a little bit different because this time we're doing it with the axis rather than doing it with PLT, but we can still do it nonetheless. So over here we can say axis, and this time we can say dot set underscore, we can say x label, invoke that, and we can say days for this. And we can do the exact same thing for, as you can imagine, the y label. So we can say set y label, and this can be, we can say infection infection rates. And also we can say axis dot set title. Go ahead and invoke that. And what do we call this here? Just infection rates over time. So let's go ahead and Control Shift, and there we go. We have created pretty much the exact same graph, but this time we did it with figures, which is the recommended way of doing things. So why is it the recommended way of doing things? Why is it the more conventional way? Well, it's a more conventional way because we can actually do more manipulation to our figure than doing it this way. So for example, let's say that right here in this graph, what I want is another graph located somewhere right over here. And it's just kind of a zoomed in version of it at a specific point in time. So maybe we really want to zoom into this portion right over here in this data set. And I want to just display it on this figure right over here. So we can actually do that with a figure. So we can create another axis. So I'm going to say here, I'll say axis 2, and I can say that this is going to be equal to fig, and we can say add axis. And this is where I'm going to explain exactly what this is. So the first thing I want to explain is these two ladder numbers. So for now, I'm just going to say 0, 0. And then over here, remember, I want this axis to kind of be located right over here. And I also want it to be smaller. So this right over here actually determines the proportional size of the axis that we create. So what we did here was we said 1, 1, which means that it's going to be 100% by 100%. So the width is going to be 100%, and then the height is going to be 100%. But if you wanted to make it smaller, then what we can do here is we can say something like, well, 0.25, 0.25. And what this is going to mean is, well, this is going to be, if I were to go ahead and create this, you can see now we get this box right over here that is 25% in width and 25% in height. So that is exactly what this means. Now, what do these two mean? Well, you can probably imagine this right over here is going to determine the position of this axis. So right now it's at 0, 0. But if we wanted to move it up, for example, maybe up 50%, we would say 0.05. And you can see now it is right over here. Now, if I wanted to move it to the right a little bit, maybe I want to move it to the right 25%, I can say 0.25. And there we go. So now we have this other axis. And of course, we can also label it if we want to. We can do whatever it is that we want. Now, what we want to do is pretty much just graph the exact same data, but zoom in a little bit on a specific portion. So let's go ahead and actually just, well, plot that data onto this axis. So I'm going to say over here, I'll say axis, and I'm going to say that this is going to be equal to, or rather axis.plot is going to be xy. And what this is going to do is just give us the exact same data, but just in a smaller version. But now what I want to do is I want to zoom in. Now, of course, how do I zoom in? Well, we've learned this before. We're going to zoom in with the X limb as well as the Y limb. So let's go over here, and I'm going to say x2 dot, I'm going to set the X limit, and I'm going to set it from, let's say I want to zoom in from 3 to 5. I want to get kind of like this portion right over here. So I'm going to say 3 to 5. So if I were to go ahead and set this, you can see we get this limit from 3 to 5. Okay, so this is looking good. But now I also want to limit the y-axis. So what we can do here is, well, you probably imagine, set lim, we can say y lim. And y lim is going to be from 10 to 30, let's say. And now you can see here we get this kind of zoomed in version. Maybe this piece of data is very, very important, and we really want to grab people's attention, and we want people to actually see it. So now we kind of get this little zoomed in version, and we can also give this zoomed in version a title. So I can just say here dot set title, and I can say maybe this is the breaking point. I don't know what they call it here. I'm just gonna kind of like use just some random random biology point. So right here at day 4, this was the breaking point. This is where it started to become extremely exponential or whatever. It doesn't really matter. But you can see here we can also give it a title. We can also give it an x-axis and a y-axis. So we can do the exact same thing with this other axis that we can do with this one as well. Okay, so this looks pretty good. I'm kind of proud of it. Now let's go ahead and actually create another figure. And let's say this time we want to compare the infection rate of a bacteria versus the infection rate of a virus. And we want to kind of have those two data point entries in the same exact figure, but on the same exact axis, not two different axes. So let's go over here and let's just create that data for now. So we're going to use for the bacteria, the X and Y, but let's create another data point that's just going to be linear for the virus. So I'm going to say A is equal to np.arrange, np.arrange, and we're going to say from 0 to 11. And to make this linear, I'm just going to say B is equal to A times 3. And that's just going to give us some linear data. So now let's go ahead and actually create a figure. So I'm going to say fig, and I'm going to say that is going to be equal to plt.figure. And now we have that. So let's go ahead and create an axis. So I'm going to say fig.add axis, and I'm going to say 0, 0, 1, 1. I hope this makes sense right now. So we should get this axis right over here. So now what I want to do is, oops, this should be all in the same cell. That's why we didn't really get anything. So let's go here. There we go. So now what we want to do is we want to plot some data. So we're going to say axis dot plot, and I'm going to plot X and then Y. So there we go. Now we have the bacteria. And of course we can go ahead and actually give this, let's go ahead and just copy the this right over here. We're going to copy the labels as well. So now I have infection rates over time. So now we have the days and then the infection rates. And this right here is the bacteria. But I also want to graph on this exact same axis the virus. So we can actually just do that really easily by just saying axis.plot and then A and then B. And there we go. So now we have two graphs there that are representing the infection rates of the bacteria and then the infection rate of the virus. Now, the only issue that we are facing here is, well, which one's the bacteria and which one's the virus? I mean, I just told you that the bacteria is the exponential one, but how, if I'm just looking at this graph, how am I supposed to know that? Well, typically, it's done in situations like this is we create a legend. So over here, what we can do is create a legend, and we actually first label all of these graphs inside of the plot. So I can just say right over here, I can say comma, and then I can say label, and I can say bacteria, and then over here I can say label, and I can say virus. And by the way, this is of course all fictional data. I'm not saying that bacteria always grow exponentially or infect people exponentially while viruses are linear. You know, it all depends, right? You know, you're just saying bacteria or virus on its own, it's you know, everything's different. You guys probably get that. I'm not gonna have to explain it. So over here, what we can do is we can give these two graphs a label, and that doesn't really do anything until we say I want a legend. So I can say axis.legend, and what that's going to do is say, okay, the blue one's bacteria, and then the virus is the orange one. Okay, so that's pretty much it. Now, one thing we can also do to kind of increase the resolution of the image is we can say DPI is equal to something like 100. And what that's going to do is just increase the overall resolution of the image, just so we can look a little bit better. Okay, so let's go ahead and actually move on. So now let's say that, okay, I like this graph, but maybe I want it on different graphs. But I don't want to have to create another axis and kind of figure out exactly where I want to place it. One thing that we can do is create subplots. So let's go ahead and actually do that. So I can say here fig, and then I can say axis, and I can say here that that is going to be equal to plot.subplots. And then over here, I can specify how many rows and columns of plots do I want. So I can say n rows. And if I just want one, I can just say this and I get one. And this is pretty much what we got before. But if I want two and I want them on two different rows, I can say, well, something like this. So I can say, I want 2 rows. So I get one plot right over here and then another one over here. If I want 4, but I want maybe, let's say, you know, one over here, one over here, one over here, one over here, then what I would have to do is specify the column. So I can say n columns and I can say 2. So now you can see that we get kind of a 4 by 4. Maybe we want 2 and we want to place them side by side. Well, over here we can just say 1 row, and that's just going to place them over here. And of course we can change the size of this, but for now let's just go ahead and just say a 2 by 2. All right, so this is looking pretty good. And now we can pretty much use this right over here, the axes, to plot whatever data that we want. So let's say we want to plot the bacterial data right over here on this axis right here, and then we want to plot the virus data on this axis. So how are we going to do that? Well, what we're going to do is very simply say axis, and then we have to specify exactly which axis we want to utilize. So I want to utilize the first one on the 0th row. So we're going to go ahead and actually index this. So this row is index of 0. This other one's index of 1. So on this 0th row, and then on the 0th column. So this column is 0, this column is 1. So I can say 1, and then I can say dot plot, and I can say x, y. And of course I can do all of the exact same things. So let's just do this in the same cell so we can see this. So you can see here, oh sorry, this should be 0, 0. And that's going to go ahead and plot it right over here. Now again, we can always do the exact same things. We can create a title, we can create an X label, we can do all that, but this time we have to use, you know, the syntax over here to specify exactly where we want it. All right, so that's pretty much that. So now I kind of encourage you maybe to pause the video and try to label the or plot the virus one right over here in this kind of bottom right corner. Now I'm going to assume that you did that, and I assume that you did something like this, x1, because we want to use this row, and over here we can just say 1 dot plot, we can say a b, and there we go. That is looking pretty good. Now, one thing that I also want to show you with plots is that these plots kind of really seem quite compressed. So maybe, you know, I can give them a little bit of spacing, right? You know, in the world of CSS, it could be like margin. So what I could do here is I can say fig dot, and I can say I want to adjust the subplots. So I can say subplots dot adjust. And let's say I want to give them some spacing horizontally. So I can say here W space for width space. And of course, I'm going to specify a decimal saying 25% like that. You can see here now we have a little bit more spacing horizontally. Now, similarly, we can do the exact same thing vertically with H space. And let's say this one 50%. And there we go. Now we have a little bit more spacing. Okay, so that's pretty much the introductory guide to Matplotlib. It's actually a pretty easy library to understand and learn, but it is really, really powerful and allows us to visualize our data set. I'll see you guys in the next one.